So now we'll see some practical challenges associated with input quantization error. Okay, how to solve some real challenges due to input quantization error. So question number 1, find the steady state variance of noise. Find the steady state variance of the noise in the output due to quantization of the input. Quantization of input for the given first order system. Y of n is equal to a into y of n minus 1 plus h of n. Okay, so first step, this is a question given. We have to find the steady state variance of the noise in output due to input quantization. Okay, now first step, what we'll do is we'll take Z transform. We'll take the Z transform of this given equation. Since no initial conditions are given, we can directly write it as y of z is equal to a. For y of n minus 1, we can use the time shifting principle. So it is z inverse into y of z plus h of z. Okay, now we have to find the system function. H of z is equal to you cross multiply these terms, so y of z minus a z inverse y of z is equal to x of z. So y of z by x of z will be equal to 1 by 1 minus a z inverse is nothing but h of z. Okay, now this is given h of z. H of z is 1 by 1 minus a z inverse. We want to find h of n. H of n is, so first step is take z transform and find the system function. Find the system function. That is my first step. Step 2 is finding the inverse z transform. Inverse z transform h of n is equal to, so for this one we can easily say that it is a power n u of n. Okay, for z by z minus a, the inverse is a power n u of n. Okay, so that's standard, we can use like it as a formula. Okay, so a power n u of n. Okay, we'll first do by, I have two methods for you. I'll do first the most common method will go. Okay, so sigma e square is given by we can also do the same method by using residues method, but here we'll limit it to the impulse response, using impulse response itself. Okay, sigma e square into summation k equal to 0 to infinity h square of n. Okay, that is a formula to find the value. Okay, now we'll have to questions, nothing is given about sigma e square, so we will retain it as such. Summation k equal to 0 to infinity, what is h of n? It is a power n u of n. Okay, so the whole square. So u of n is nothing but it contributes, u of n tells you the signal can only run from 0 to infinity, and the amplitude and so it will, and its amplitude is also 1. Okay, so we can easily write this as sigma e square summation k equal to 0 to infinity a power 2n. Okay, u of n has a magnitude 1. Okay, Now if you expand this, okay, if you expand this is an infinite geometric series, 1 plus a square plus e power 4, and it goes on up to infinity. So for this infinite geometric series, we have the formula 1 by 1 minus a square, 1 by 1 minus a square. Okay, so this is my answer for this challenge. The variance due to output noise is given by sigma e square into 1 by 1 minus a square. Okay, sigma small e square. This is my output answer. Okay, so this is how you solve these kind of challenges. Thank you.